आज की इस Committing to a STEM degree means sacrificing 4 years of your life, steep tuition, and immense mental energy. In high school, studying distant galaxies and dark energy feels romantic. College coursework quickly trades that starry-eyed wonder for grueling abstract mathematics. This leaves you with a serious question to answer. Is a physics degree an underfunded passion project for aspiring academics, or a secret backdoor into the world's most elite industries? To figure that out, we're stripping away the astrophysics romanticism to calculate the true market return on this investment. To evaluate physics accurately, you must treat the degree as an aggressive, high-risk investment in your own cognitive capital. This chart maps the landscape of college degrees based on two distinct metrics: career versatility on the horizontal axis and academic rigor on the vertical axis. Traditional linear vocational programs sit comfortably in the lower quadrants. Degrees like accounting or civil engineering offer specific, narrow utility with clear paths. Physics lands in the extreme top right corner. It sits entirely alone as an extreme outlier in both rigor and versatility. Because the coursework is exceptionally difficult, it forges a universally respected skill set. Employers view it as proof of a high cognitive floor, evidence that you can solve any problem they throw at you. Your final decision rests on whether the extreme academic pain of reaching that top right quadrant is worth the wide-ranging career options that follow. Earning that statistical analysis. This flowchart shows how those abstract mathematical inputs feed into a cognitive bootcamp, ultimately outputting into elite problem-solving capabilities. Those problem-solving skills allow graduates to bypass traditional candidates, branching directly into highly competitive, data-heavy hubs like data science, quantitative finance, and software development. In fact, physicists who are successfully pivoting into high finance and tech frequently adopt the title of quant, or quantitative analyst. Because their highly specialized analytical skills are very rarely found in the general applicant pool, these specific roles command premium salaries. Wall Street and Silicon Valley aren't paying for your knowledge of gravity. They use the theoretical workload of a physics degree as a highly efficient vetting mechanism. To understand the value of that workload, we have to compare physics against its two closest neighbors, pure mathematics and applied engineering. Physics operates as a theoretical middle ground. It bridges the gap between the pure abstraction of math and the strict physical practicality of engineering. This unique middle ground grants you the distinct ability to seamlessly design, simulate, and optimize massive, complex systems. Unlike a traditional, mechanically focused engineer, you will sacrifice immediate, hands-on physical building experience in favor of this advanced simulation capability. The major benefit of that trade-off is that you are never locked into a single physical discipline or material reality. Studying physics completely trades the safety of a specialized engineering license for the ultimate freedom to innovate across multiple modern technologies, from renewable energy grids to advanced medical imaging. Despite the heavy focus on research in college, the vast majority of physics graduates will never work in academia or a laboratory. This creates the title paradox. Upon graduation, you will rarely, if ever, apply for a job with the actual title of physicist. That reality creates friction when you deal with traditional HR departments or business recruiters who don't immediately grasp the practical value of your background. This translation matrix shows how abstract physics skills on the left, like quantum modeling, translate into concrete business value on the right, like risk algorithms. Once properly framed, these translated skills match exact requirements for highly sought-after roles like technical consultant and data analyst. However, this translation process demands significantly more interpersonal and communication effort on your part compared to following a predefined vocational track. A physics degree lacks a built-in job title, providing only a toolkit that you must actively and aggressively sell to the market. We must evaluate a degree in physics entirely as an aggressive, high-risk, high-reward career investment for your professional future. You are explicitly trading a predictable linear path for extreme professional versatility. The premium earning potential is very real, but it is exclusively reserved for those willing to endure heavily taxed cognitive inputs over 4 years. Ultimately, this decision comes down to your personal psychological appetite for wrestling with deeply abstract problems. physics changes how you think, requiring you to rebuild your logic from the first principles of the universe. This scorecard determines if you are the right fit. The left lists the ideal candidate. The right shows who should pass. The ideal candidate thrives on breaking down complex problems. They are pragmatic optimizers seeking an industry-agnostic career with a high earning ceiling. This profile succeeds by leveraging their analytical toolkit to pivot effortlessly between tech, finance, and engineering as markets evolve. Conversely, pass on this degree if you require predictable certainty, a guaranteed job title, and a linear vocational path. If you are averse to years of abstract mathematics and just want to build things immediately, opt for a direct engineering or computer science route instead. Choose physics if you want to master the fundamental rules of the universe and possess the ambition to leverage that mastery anywhere in the economy.